One day, a group of friends have decided to gather after a long time not meeting each other, and the story continue from there. Hazi crashing to the gathering at the dinner, meanwhile his friends already waiting for him.
Hi guys, sorry I'm late for the gathering. Guys, how about we go to a trip to Penang next weekend?
That sounds like a good plan. I need to take a break from my work.
Yeah, me too. My mind need to be refreshed.
I'm suggesting we take by train. How's that sound?
We think we will take by driving a car. How about you, Farhan?
I think I want to ride on bike to Penang. How about the last one need to pay everyone dinner when we arrive to Penang?
That's decided then. Let's meet out there.
On the day of traveling, the group decides to travel at the same time as the train that Haziq take to Penang around 8 AM.
Finally, it's the day. I will show them that I will arrive first. Ho ho ho.
After a few hours, Haziq's the one that arrived first to Penang was followed by Dine and Hidayah and lastly Farhan.
Haslit, how come you're the one that arrived first over here instead of us?
Let me explain it to you about the bullet train. So, you guys must have heard of bullet train, right? It's the fastest train in the world. In engineering terms, they are called maglev train. Maglev is a derivation from magnetic levitation, which basically means the trains are levitated by magnet. Yes, you heard it right. It's a floating train.
Wow. So what makes this train so fast?
That's where the physics kicks in. The both sides of the train are installed with superconducting magnets. Same goes with along the guideway track. Superconducting magnets are a type of magnets that has almost zero resistivity. This allows higher efficiency of power usage. Maglev train starts moving same goes like a normal train do, by using a wheel. But when it reaches a certain speed, it will start floating. This will eliminate the frictional problem.
Care to explain more on how does a train start floating? It doesn't make any sense to me.
When the train travels with a high speed, the conducting magnets on each side of the train will induce a current on the coils. The coils generate an upward component of magnetic force on the superconducting magnet and levitates the train.
Then, how is it going to move? Is it floating?
So when the train starts floating, it's already quite fast. But that's not the true speed of the train. It can go much further than that. The one who moves the train is the alternating current on each side of the guideway, producing an alternating series of north and south magnetic poles which pull and push the train magnets. If the train needs to be stopped, the current will be set to reverse. Same concept with when you try to touch the two magnets with the same pole, it will push each other and vice versa. This can be explained by referring to Faraday and Lenz's law. Now, imagine the loop is the guideway, where epsilon is the electromotive force, n is the number of loops, and phi is the magnetic flux in Webers through a single loop. When a conductive loop experiences a changing magnetic field, it generates an electromotive force around the circuit. This EMF is 90 degrees phase ahead of the field. Since the field and potentials are out of phase, both attractive and repulsive forces are produced. Although the EMF is at 90 degrees, the loop still has inductance. This inductive impedance tends to delay the peak current by a phase angle dependent on the frequency, where inductive impedance of loop increases with frequency. Where K is impedance of the coil, L is the inductance, and R is the resistance. At low frequencies, the phases are largely orthogonal and the currents lower. Thus, no significant lift force is generated. But at high frequencies, the inductive impedance dominates. The current and the applied field are virtually in line. This current generates a magnetic field that will levitate the train. That will explain why the train only starts to float at high speed.
Please have mercy on my wallet, you know.
Well, bro, it's your loss, right? Just accept it.